Welcome to this video where we will explore a topic that is crucial to the future of technology and innovation, the governance of artificial intelligence in the United States. As AI becomes more and more pervasive in our lives, it is essential to put in place a robust framework that ensures the safety, ethics, and prosperity of this growing sector. How can the United States create an environment where AI not only drives innovation, but also protects the rights and safety of citizens? This is what we will discover together, analyzing the challenges and possible solutions to establish a safe and thriving AI sector. Objectives. This policy brief is motivated by two objectives. To maintain U.S. leadership in AI, which is vital to economic progress and national security, while recognizing that AI, if not properly supervised, could have significant adverse effects on society, including undermining economic and national security interests. To achieve broadly beneficial deployment of AI across a broad range of domains. For AI to be beneficial, it is necessary to prioritize safety against dangers such as deep fakes, individual privacy and autonomy, by preventing abuses such as excessive surveillance and manipulation, security, by minimizing the risks created by AI deployment, particularly in already regulated domains such as health, law, and finance, shared prosperity, by deploying AI in ways that create opportunities and gains that are broadly accessible through AI, and democratic and civic values, by deploying AI in ways that are consistent with societal norms. Core principles. With these goals in mind, we offer the following discussion and guidance on how AI governance might be implemented. It is important to subject AI systems to a combination of regulation and liability law to ensure that AI is developed and deployed in ways that facilitate its beneficial uses today and in the long term. Users, and the general public, should have a clear understanding of what they are and are not getting from an AI system, and should be able to trust this understanding through mechanisms such as contractual relationships, disclosures, and audits. To achieve this, the standards, regulations, and institutions that shape AI need to evolve alongside it. As technology tends to evolve rapidly, existing approaches to oversight or regulation should be extended, where possible, to align AI with current standards and laws, as opposed to de novo approaches to AI regulation, such as those pursued in the EU. In other words, the first step in AI governance should be to ensure that current regulations apply to AI, where possible. If human activity without the use of AI is regulated, then so should the use of AI. The development, sale, and use of AI systems should, to the extent possible, be governed by the same standards and procedures as humans acting without AI in AI application domains, e.g., healthcare, law, hiring, and finance. Among other things, this will inherently ensure that many higher-risk applications of AI are covered, since these are areas for which laws and regulations have already been developed. One question will be how to deal with laws that rely on intent. AI currently has no intent, but those who develop and use it may have intent. This approach of enforcing existing laws will also prevent AI systems from being used to circumvent existing regulations. This type of approach is already used in some areas. For example, self-driving cars are held to the same standards as those driven by humans. General-purpose AI, such as GPT-4, or chatbots built on it, such as ChatGPT, are discussed further below. This approach of extending current legal frameworks to activities involving AI should also apply to activities undertaken by governments, including policing, setting bail, hiring, etc. In general, laws and regulations relating to AI should be enacted and enforced by the same entity or entities that govern human actions without AI in the same domain. This may require that these entities acquire some expertise in AI, as discussed below. As laws and rules relating to AI develop, differences between the capabilities of AI and humans may be taken into account. AI will have capabilities that humans do not have, for example, to find patterns or consider counterfactual propositions. This may justify holding the use of AI for certain purposes to higher standards than those applied to humans acting without AI. For the approach described in this section to be successful, AI system providers should be required to identify the intended purposes of an AI system before it is deployed. Regulators could issue guidance or rules defining how intended uses should be described, and/or courts could develop case law defining what intended use disclosures are adequate to meet particular purposes. The latter solution, while leaving more ambiguity and risk, could allow AI providers and their customers to determine what types of information are needed, and could allow more flexibility as AI evolves. But this will only work if steps are taken to ensure that those who purchase and use AI have the ability to impose effective requirements on AI providers and can be confident that any contractual terms they negotiate will be enforceable. Moreover, the more open approach may be more appropriate for some uses of AI than for others. Different states may also experiment with different approaches in areas of application that are regulated at the state level. Defining what AI is important, but difficult, but is often necessary to determine which systems would be subject to regulatory and liability regimes. The most effective approach may be to define AI systems based on what the technology does, such as any technology that makes decisions or recommendations, or generates content, including text, images, video, or audio. This may be less problematic than basing a definition on characteristics of the technology, such as human-like, or on technicalities such as large language model or foundation model, terms that are difficult to define or are likely to evolve over time or become obsolete. Furthermore, approaches based on definitions of what the technology does are more likely to align with the approach of extending existing laws and rules to activities that include AI. Audit regimes should be developed within the framework of the approach described above. To be effective, auditing should be based on principles that specify aspects such as the audit objectives, i.e., what an audit is designed to learn about an AI system, such as whether its results are biased in some way, whether it generates misinformation, and/or whether it may be used in unintended ways, and the information to be used to achieve these objectives, i.e., the types of data that will be used in an audit. An effective audit ecosystem could develop in a number of ways, not necessarily mutually exclusive. For some uses, the government, federal, state, or local, could require an audit to be conducted by a vendor, regulatory entity, and/or user before and/or after a system is deployed, particularly for high-risk uses such as already regulated application areas, e.g., healthcare. A system could also develop more organically, with users requiring or conducting audits before or after deployment, and courts assessing liability more harshly when an AI system does not perform as intended or violates a regulation, and no proper audit has been conducted. Audits could be conducted by third parties, by users, or by the government. Any audit should protect the intellectual property of the AI system vendor and the user. Audits can be easily manipulated to avoid revealing existing problems or, conversely, to suggest that something is wrong when it is not. This will require the development of public standards for auditing. These standards could be set by a non-profit entity, such as one analogous to the Public Company Accounting Oversight Board, CABE, or by, or with, a federal entity such as the National Institute of Standards and Technology, NIST. It is important to understand the limitations and requirements of different types of audits. For example, prospective audits allow for testing of a system before it is used, which can be useful in high-risk environments. However, the distribution of data during these a priori tests may be very different from that encountered during actual use. For example, an audit of an artificial intelligence system that will be used to identify good job candidates may use a different distribution of candidates than that which will appear in the actual pool of candidates. Retrospective audits, on the other hand, may require access to information that is confidential to the organization being audited, so it will be important to establish clear guidelines and define responsibilities for data privacy. Explainability, the automated explanation of how an AI system reached a conclusion or generated an outcome that is both accurate and human understandable, is not possible today and may never be. But AI systems can and should be more interpretable, that is, they should provide insight into the factors that influenced a recommendation or the data that was used for an answer. Improving interpretability should be encouraged in ways that are not overly prescriptive about the technology, as methods will continue to evolve rapidly. The government could encourage greater interpretability through a regulatory system that imposes more requirements on AI systems that are less likely to be interpreted, or the courts could develop a more stringent liability regime for such systems. Training data plays a central role in many AI systems. Many data sources, particularly those from the public internet, contain inaccuracies, biases, unintended disclosures of private information, and various flaws that AI systems should be designed to guard against. Clear statements about the intended outcomes for AI systems, as well as mechanisms such as testing, monitoring, and auditing, both for specific application domains and for general use, are important, in part, to limit the problems that can arise from problems in the training data. AI stacks for specific applications. It is important to recognize that AI systems will often be built on top of each other. For example, a general-purpose system like GPT-4 may be the foundation for another system used for hiring. We consider an AI stack to include any AI system that can serve as a component of other systems, including but not limited to base models. This is similar to general software systems, which may consist of many components connected by application programming interfaces, APIs, and are commonly referred to as a software stack. In general, both the provider and end user of a service provided by an AI stack would be responsible for its operation, but would have to depend on the components of the overall stack to do so. So, for example, a stack deployed for hiring purposes would be primarily the responsibility of the provider and user of the entire stack, and the provider would be subject to the regimes described above. But when a component system in a stack fails to perform as intended, it may be reasonable for the provider of that component to share the responsibility. To facilitate this, those building systems that rely on general-purpose AI should request information about how the general-purpose system would handle the particular intended function, and request enforceable assurances that the general-purpose system will perform as intended. As noted above, this presupposes a legal environment in which contractual safeguards can be required and enforced. It is worth noting that AI components in a stack can interact in unexpected ways, hence the importance of considering all components of a stack together, for example by auditing these systems, both before and possibly after deployment. One of the goals and tests of a regulatory and liability system is that it should, in effect, clarify what constitutes a fork in the toaster situation, i.e. when a user, rather than an AI provider, is responsible for a problem because the AI system was used in a way that was clearly not responsible or intended. Such situations can only be identified if providers specify what the appropriate uses are, if there are good practice safeguards against other uses, and if the legal responsibilities of providers are clearly delineated and widely understood. In addition, the uses and limitations of AI must be widely understood by users. By analogy, one cannot be held personally liable for putting a fork in a toaster if neither the nature of toasters nor the dangers of electricity are widely known. What a reasonable user, or a reasonable developer of an application, is expected to know is likely to change over time. In most cases, the provider of the AI system should be held liable for a problem unless it can demonstrate that a user should have known that a use was irresponsible and that it could not have been foreseen or prevented by the provider. General-purpose AI. Vendors of general-purpose AI systems such as GPT-4 and general applications based on them such as ChatGPT cannot be expected to disclose all intended uses of their systems. Yet these systems carry additional risks due to their wide use, availability, and the ability for applications such as chatbots to interact in ways that appear human to users. Despite the broad areas of potential use of general-purpose systems, governments could require that general-purpose AI systems disclose whether certain uses are intended, such as providing medical advice, and have safeguards against unintended uses, which could be defined in regulation. Regardless of statements of intent, general AI systems, like all others, would have to comply with laws and regulations governing activities that would be covered by humans acting without AI, see above. In addition, laws and/or case law could impose more severe liability for problems resulting from uses that the provider could have reasonably anticipated but failed to prevent through safeguards or adequate warnings or instructions to the user. Any warnings or instructions must be provided in a way that the user is likely to see and heed. Small print that a user is unlikely to read is not enough. General-purpose AI providers could be required to monitor the use of their AI systems, much as pharmaceutical companies are often required to monitor the effects of their products once they are on the market. This will be particularly important if general-purpose AI systems develop new capabilities as they are used, rather than simply changing when an updated system, such as GPT-4, is released. The government could specify the types of problems that providers are responsible for discovering, reporting, and addressing. The government could also require that new general-purpose AI systems be piloted before being widely deployed. It is worth noting that what counts as general-purpose AI will likely change over time as the technology develops, and regulation will need to be flexible enough to evolve with the technology. In some areas, AI regulation should go beyond what is typically required of human actors, such as when AI has capabilities that humans do not. One such area is the use of AI to create fictional but realistic images, videos, or sounds that resemble real places and people, living or dead, sometimes called deep fakes, especially when used without permission. While humans have long been able to manipulate images, AI makes creating a realistic fake as easy as taking a real photo and also makes it easier to target the recipients of disinformation. Another area is privacy and surveillance. While pre-AI technologies were capable of violating individual privacy and engaging in intrusive surveillance, these capabilities are greatly amplified by advances in AI. In addition, the government should require that images created by AI be clearly identified as such, both through labels typically visible to humans and through machine-detectable means, such as watermarking. AI Regulatory Agency. For AI oversight that goes beyond the scope of currently regulated areas of application and cannot be ensured by audit mechanisms and a system similar to that used for financial audits, the federal government may need to create a new agency that would regulate these aspects of AI. The scope of such a regulatory agency should be as narrow as possible, given the broad applicability of AI and the difficulties of creating a single agency with a broad scope. The agency could recruit highly qualified technical staff who could also advise existing regulatory agencies that deal with AI issues, in line with the points above. This task could also be assigned to an existing agency, but any existing agency selected should already have a regulatory mission and the prestige to attract the required staff, and it should be free of any political or other controversies related to existing missions that could complicate its oversight of AI. A self-regulatory body, such as the Financial Industry Regulatory Authority, FINRA, in the financial world, could take on much of the detailed work under federal control by developing standards and overseeing their implementation. Even with a new AI agency, regulation of AI systems for specific uses, such as aiding medical diagnosis, would remain the responsibility of the existing agency governing that area, such as the Food and Drug Administration, as described above. 6. Other aspects of governance. One goal of any regulatory or accountability approach should be to encourage the private sector, universities, and research organizations to conduct more research into how AI systems can be beneficial, as defined in the goals section of this report. Just as regulation of the automotive industry has incentivized manufacturers and universities to conduct research into how to make vehicles safer and less polluting, regulation of AI should incentivize companies to conduct more research into how to make AI systems more beneficial, including, for example, by making them easier to interpret. In addition, the government should increase funding for public research on these issues. Public research into large-scale AI systems, such as large language models, on which other AI systems are built, is particularly important. Developing beneficial AI systems requires a clear framework for intellectual property, IP, rights. It is important that human creative efforts remain encouraged in a world with AI systems. While court decisions affirm that authors and inventors must be human, so AI does not benefit from any intellectual property rights, questions remain about how intellectual property laws apply in the context of AI systems, such as copyright, which gives creators of a work rights over how the work is distributed and used in other works. In particular, while it has always been possible to create works that infringe copyright, AI-generated content appears poised to dramatically increase this phenomenon. It is worth noting that the question of whether something constitutes infringement is ultimately determined by case law and litigation. uncertainty about how creators can protect themselves against potential infringements and easily identify them, as well as who or what organizations would be liable, complicates the use of generative AI. This is changing rapidly. For example, Microsoft has announced that for paying customers of its generative AI products, the company will defend and pay any adverse judgment or copyright infringement settlement generated by its products, provided the customer uses the safeguards and content filters built into the products. There are also questions about the use of personal digital data that are much broader than AI, such as in social media, and should be addressed in a way that does not constrain AI any more than it does other technologies. AI systems are currently trained on the assumption that copyright does not prevent such use, but this assumption is contested by content owners. Such questions frequently arise with new technologies. A relevant example is the Google Books case, filed in 2005 for copyright infringement by Google when it scanned a large number of books to make them available online. In 2015, the courts upheld a district court's decision that this was not an infringement because the material was not reproduced. Rather, the resulting search tool provided information about where copyrighted materials could be obtained, with permission. While training AI systems, as in the Google Books case, does not directly produce content, an AI system differs in that its use may generate infringing content. It is not yet clear whether illegal content generated by AI will be easier or harder to identify than illegal content generated by humans. On the one hand, it is likely that more illegal content will be generated, but on the other hand, a copyright holder could in principle ask an AI system to demonstrate that it produces illegal content, without having to undertake a search for specific instances of possible infringement. It is also possible that artificial intelligence systems will be developed to better indicate which original sources are relevant to a given production, thereby allowing the assessment of the possibility of infringement. Open source can both help prevent problematic uses of AI, by allowing more people to discover flaws, and increase such uses, by facilitating the creation of AI systems that may cause harm, including by circumventing safeguards, and by making their development and distribution more difficult to control. Open source developers should follow the same practices as commercial vendors, clearly stating intended uses and following best practices for safeguards against other uses. Service providers that use open source AI as components should take responsibility for the behavior of those components. While these are similar issues to the use of open source software, the greater challenges of interpreting and understanding AI systems compared to standard software can increase risks. In summary, it is unclear whether and how current regulatory and legal frameworks apply to AI, and whether they are up to the task. Vendors, users, and the general public are thus in a situation of caveat emptor. There is little to deter the release and use of risky systems, and little incentive to proactively discover, disclose, or fix issues. Those who rely on general models lack sufficient information about the systems that make up their stacks and have little recourse when problems arise. Greater clarity and control over AI are needed to facilitate the development and deployment of beneficial AI and to ensure that the potential benefits of AI for all Americans are realized more fully and harmoniously.